Okay, for condensed form. The 2, the 1/2, and the 3 all become a what? 2, 1/2, 3. Okay, they all become a what?
Exponents.
Exponents. Okay, so this becomes natural log x squared minus natural log of x squared plus 5 to the 1/2 power plus natural log of x plus 3 cubed. What's the 1/2 power going to become though? Square root. You got to make it a square root. Can I leave it as 1/2 power? You got to make it a square root. And now you got to go in order here. Order of operations. So I have got to do this right here first, which means if it's a subtraction, what do you actually do to the expressions? Divide them. So this will be the natural log of x squared over, I'm going to go ahead and make that the square root now. Square root, should be x squared. X squared plus 5 plus the natural log of x plus 3 cubed. Well, what do we do when there's a plus to the expressions? We don't divide them, we multiply them. Now I'm going to do this in 2 steps. I know you probably do it in 1, but just to demonstrate something, every now and then I'll get some students that will write it like this. And although it's not incorrect, it's not simplified. It's not written in the proper format. It's got to be one numerator, one denominator. Question is, does that x plus 3 cubed go in the numerator or denominator? Has to go where? Numerator. So now my final answer, 1 natural log ln x squared times x plus 3 cubed over square root of x squared plus 5. All right, now every now and then, like you can leave that. Every now and then I get somebody that wants to cube that and then distribute the x squared. And that's got to take forever. Like if you come across a problem on a test and you're like, there's no way he wants me to do this, ask. Okay, don't just start doing all this crazy amount of work. I'll tell you, yeah, you need to do that or no, just leave it like it is. All right, so that's your answer there. Second one, expanded form. All right, first step. What do you got? What do you got for your first step? Oh.
First, I did like the little exponents. Oh yeah, I took. What's the word? I took the first one and then I did like the y and I subtracted like the log of y squared.
Okay, so you take the log of the numerator. I'm hoping this is what you're trying to get to. Minus the log of y squared. Split it apart like that. I'm hoping. Exactly. All right. Now, x cubed times square root of z. That is a product. Split that up to a plus. So log x cubed plus log square root of z minus log of y squared. All right, now we take the exponents, put them out in front. This becomes 3 log of x. Cannot leave square root of z. Square root is the same as what power? 1/2. So that will become 1/2 outside plus 1/2 log of z minus 2. That's a 2 there. Log of y. Okay, 2 log of y. I looked at the My Math Lab grades. They seem pretty good. Like some of you might miss a true false. So instead of 100, like a 98.4 or whatever. True false. You need to go back and look at those again. Okay, make sure you know those. All right. So you got to just be careful there. Hey, one big thing that you got to watch. It'll come up a little bit later on. That tends to show up. The log of x over 4 can be written as the log of x minus the log of 4, right? When you take the log of a quotient, you can write it as a subtraction problem. However, if you have, say, the log of 10 over the log of 7, you cannot write that as a minus problem, subtraction problem. It has to be a single log of a quotient. Okay, there's going to be a temptation to want to say, oh, I'm going to make this the log of 10 minus the log of 7. No, cannot do that. Okay, just be careful. It has to be a quotient. It has to be a quotient of the log of a single quotient. And then they split it apart. If there's 2 logs, top and bottom, you got to keep it. Not do anything else. All right, so be careful. You'll see where that comes up here in a little bit. All right, let's anything that you wanted from the my math lesson last night. Double check those true falses. Get down. And then we'll write those down at some point. And all right, we're going to finish up. So take a look at the rest of your those notes. And then we are going to do, there's no guided notes for the next section, so you might want to have a piece of paper here. All right, kind of read through that back page there, or that start of that first page. Half-life. We're going to get into half-life, which is part of exponential growth or decay. And I kind of assumed you had a little bit of knowledge. You may have seen it at some point, but let me just real quick talk about it here. All right, so in this case here, in an experiment, 18 grams of a radioactive element, sodium-24, decayed to 6 grams in 24 hours. Find its half-life to the nearest hour. All right, I want to make sure you understand something about a half-life. This isn't part of the problem, but just overall. Let's say we start out with 200 grams of something, and I tell you its half-life is 4 hours. Well, you kind of think of the terminology here. So after 4 hours, how much should be left? Yeah, so you take half of it. You take half of it. Now, here's what you got to watch. At the end of the next 4 hours, it doesn't go down to 0. You don't lose 100 grams every time. You lose half of it every time. So at the end of the next 4 hours, how much we got left? 50. So after another 4 hours, there will be 50 grams. And then after another 4 hours, there will be 25 grams. All right, so that's kind of how the process of half-life works. Medicine. Sometimes you talk about the half-life of medicine. When you take, a pill, it's going to decay in your body. And so you might take the next pill in 4 hours or 6 hours or 8 hours based upon the concentration of the medicine in your system. Okay, so you don't want to take it every 2 hours. You have too much. You don't want to take it too long apart, or you won't have enough concentration. All right, so in this case here, we got 18 grams we start with, and we notice at the end of 24 hours, it's down to 6 grams. We want to determine its half-life. So we're going to start with this A equals A sub 0, e to the kt, and we're going to need to find K. You cannot solve that problem just the way it's set up until you find K. So take the piece of information we have, plug them in, and we got to figure out how to get K. What's going to go in for A? The 6 will go in for A. A sub 0 is our initial amount, which is 18. E is E. And the time is what? 24. 24 hours. So I'm going to make this 24K. 24 carat. For now. What do I do first? Okay. You want to get rid of that 18. So divide both sides by 18. 6 over 18. All right. Now, if you use your calculator and you divide, it's going to give you a repeating decimal. Okay, 0.3, you don't want to round off. So if you got something we got to round off, keep as a fraction. 6 over 18, I want to reduce that to 1/3 equals e to the 24k. All right, I'm not going to round off yet. What do we do, or how do I figure out what k is to this point? Swoop it, okay. And what does that give us, though? What does that give us? 10.
Natural log of 1/3 equals k to the k times 1.
Yep, natural log of 1/3. Now I'm always going to write that as 24k. I'm going to switch that order. Divide by 24. Divide by 24. All right, so there's my k. Now I do have enough information to finish this. So I'm going to go back up here. I know that a equals a sub 0 e to the kt. I know k, natural log of 1/3 over 24. I'm not going to plug it in yet just because I don't want to write it out the whole time. But how do I proceed? We got enough, but you just got to be careful. How do you proceed from here? We're actually trying to find what? What's that? T. We want to find T, find the half-life. So we want to find T, which will give us our half-life. But how do I set it up? How do I set it up? We started with 18 grams. If I want to know the half-life, I want to know when the final amount is what? 9. So I'm going to make this 9 equals 18 e to the kt. Divide by 18. And I get 1/2 equals e to the kt. All right, swoop it. Make it turn into a natural log. Lexi, what do you think it's going to give us? It's actually an L.
Oh, I'm sorry.
Sorry?
Ln of 1/2
Yep.
over t
Equals the exponent, which is kt. You got to put both the k and the t. Equals kt. Natural log of that constant is always equal to the exponent. So equal kt. I'm solving for t, right? Divide by what? K. Divide by k. So t equals the natural log of 1/2 divided by k. Now I'm going to come back to that in a minute. We know what k is. It's the natural log of 1/2. K is natural log of 1/3 divided by 24. All right, plug that in your calculator. Make sure you get it. Still getting a few people that are missing problems because of your calculator entry. Don't just sit there and wait for everybody else to do it for you. Make sure you enter it correctly. Make sure you get the right answer. It asks for the nearest hour, right? Just the nearest whole number. Nearest whole number. Oh, right. What did you do wrong? This is why we do this. Yes. All right, next one.
One four.
Oh, you divided that by itself. Oh, you got to divide that by. That's. Look at what you get. 15. So if you round it to nearest whole number, 15 hours. Now you can type the whole thing in at one time. I don't always like to do that just because you really got to watch your parentheses. Sometimes I'll go take the more complicated part and do that first. I would figure out what k is. I would take the natural log of 1/3 divided by 24, and I get that answer. And then I would take the natural log of 0.5 or 1/2 divided by my answer, and that's one route to get there. I mean, different routes you can get there, but 15 hours. All right, that second one down there. Ooh, wait, hold on. There is a formula for this. This formula can be useful, but I'm just going to be honest with you. 95% of the people don't remember to use it or don't know it. Okay, if you remember to use it, it can help, but you're probably going to go through that what we just did to solve it. Okay, so because once you found K, you could have just plugged it into here and we could have been done. Now I do want to show you one thing. We wrote down this right here, that T, where T is my half-life, equals the natural log of 1/2 over K. So let me put that over here. Those really are the same. How do I make the right-hand side look like the left-hand side? Okay, they're equivalent. So think about this. 1/2 is the same as 2 to what power? It is 2 to the negative 1 power. 2 to the negative 1 is 1/2. So now since I have a natural log in front of there, what can I do with the negative 1? It's a power, so we can do what? Move out in front. So now this is going to be negative natural log of 2 over K. So they're going to be equivalent. If you recognize when to use that, if you remember, that is absolutely fine. It may make a couple problems easier, but more than likely you're just going to go through the work, and it's really not much more work. All right, take a look at that one on the bottom. Again, we're going to have to find K at some point. They do give us the half-life. They tell you plutonium-241 has a half-life of 13 years. You originally had 80 grams. 13 years later, you're down to 40 grams. Another 13, you're down to 20 grams. But we cannot figure out how much would remain after 18 years just by kind of doing that little process. We have to go to our exponential growth and decay formula. Find K. Find K. All right, what goes where? What's going to go in for the A? What's going to go in for the A sub 0? Michael, what do you think? Fair.
A equals 40.
Okay, good.
A sub 0 equals 80. And T equals 13.
13, good. So we'll put T as 13. We know we're looking for the half-life, so we want to know when 40 grams are left, or we know the half-life is 13 years. Divide by 80. That is reduced to 1/2 or 0.5. That doesn't matter. All right, convert to ln form. Okay. And anytime you have a base E, you can basically go to log base E, which is natural log of 1/2 equals the power. Natural log of 1/2 equals 13K divided by 13. All right, think what you do next. What do we have to find? How much we ran after 18 years? Okay, so they're giving us what? They're giving us time. Actually, just substitute it in at this point. Okay, so we go back to this. A equals A sub 0, E to the KT. So the amount, we got to start with 80. We know K. It's a natural log of 1/2 over 13 times T, which is 18. Nearest 10th, please. Nearest 10th. Right. All you do is you plug in your calculator. You don't need to manipulate anything at this point. So 80 times E, that's a power. Natural log of 1/2 over 13 times 18. However order you want to go in, see what you get. Yeah.
30.
Where's your calculator?
Those are sorry.
So here's one that's right whenever somebody. Alright, what'd you get? Alright. Number, so what'd you get?
Oh, wait, yeah. 30.64.
30 point. Alright. 30 point. I said tenth. Either way, it's fine. Grams. 30.6, 30.64. Alright, so that's what you'd have after 18 years. Alright, we're going to go into section 4.4. Get through a good bit of it. Save us some time for tomorrow. For that one. No guided notes here. No guided notes. Did you end up getting it?
Yes, we got it.
Alright. 3.6. There it is. We will solve exponential equations today, and then we'll hit the logarithmic ones tomorrow. I don't think we're going to do the logarithmic and exponential inequalities this day. Okay, copy that down. If it doesn't come out to a nice number, we're going to round it to 3 decimal places. The first two are no calculator. Okay, so these will be like on the no calculator version. Okay, we're solving something like this. So you got 9 to the x minus 2 equals 27. When we have a case where the exponent is in the variables in the exponent, your first instinct, your first look, can you make them the same base? That's what you want to do if you can. So for this case here, what would be my base? What to a power equals 9? Same base to a power equals 27. My base is going to be 3. So this is now 3 squared to the x minus 2 equals 3 cubed. All right, use your exponent rules. So what do we do on that left-hand side with the 2 and the x minus 2? We have to do what with them? Yeah, multiply them. So when you multiply them, it's going to be like a distributing. So it's going to be 3 to the 2x minus 4 equals 3 cubed. All right, now think about that. What do I got to do? You got the same base to a power, just set what equal? 2x minus 4 equal to what? 3. That's all you got to do. So 2x minus 4 equals 3. Add 4. 2x equals 7 divided by 2. X equals 7 halves. Or 3.5, doesn't matter. For that. All right, same base. All right, number 2, same way. Is as you take a look at that. This would, again, be without your calculator. So you're going to have to know, be able to get the same base there. Watch, because there's a tendency to want to think about 4, because 16 can be written as 4 to the power, but 8 cannot be written as 4 to the power. It is a factor of both of them, but it cannot be a base. 2 would be your base. 8 is 2 to the 3rd power. $16 will be 2 to the 4th power to the x. Now, multiply power by power. So it becomes 2 to the 3x minus 9 equals 2 to the 4x. All right, once you get that, set your powers equal each other. Solve it. I get 3x minus 9 equals 4x. Subtract 3x. And negative 9 equals x. X equals negative 9. Okay, for that one. All right, copy down number 3. and at least try what we just did. You're right there. All right, well, at least try what we just did. What's the problem? Can't make the same base. Okay, 4 can be 2 squared, but can 100 be written as 2 to the power? Nope, you can try. So you cannot get them to the same base. All right, now this is where we got to use a calculator. And this is where logs come into play. When you have the variable and the exponent, you cannot make them the same base. You want to take the log of both sides. Now you can use common log or natural log. I usually use common log, which is just the regular log. So log of 4 to the x equals log of 100. All right, Michael. Why does that help us? Pressure's on.
Minus it to the other side.
Something with the x. Something with the x.
Because
Dirt.
x equals log to 100.
Not x. X doesn't equal log of 100. What can we do with the x? Remember our rules for logs, Evan?
Log 100 is 2, and then you can swoop.
Okay. You can make a log 100 too. I'm not going to do that at this point. You can get there that way. Okay, a little bit. I'm not even going to swoop because think about this. What can we do when you have a log and you have a power? The power can become a what? Power can go out in the what? Front. Power can go out in front. So log of 4 to the x. This x now goes out in front. Now you can keep that as log of 100 or you can make it 2. You're right. It really wouldn't matter. But how do you solve it from here? X divide. By what? Log of 4. Round to 3 decimal places. Let's see how many people know what 3 decimal places means. So 3 decimal places, would that be the tens, hundreds, thousands, 10,000s? 100,000s? Thousands. All right, AJ, what you get? 3.322. 3.322. Okay. Agree? 3. Okay. So in this case, if you cannot write them in the same base, got to go this route. All right, we're going to do 2 more. 2 more. All right, this one here, 8 times 3 to the x minus 2 equals 24. All right, first of all, you can't multiply 8 times 3 and make it 24. Because the 3 is to the power, the 8 is not. What can I do with that 8, however? I can divide. Okay. So that'll at least simplify it a little bit. 3 to the x minus 2. All right, that doesn't come out to a whole number, but it doesn't come out to a bad number. What is it, 2.5? You can keep it as 5 hash. You can make 2.5 as long as you're not rounded off. You're okay. Definitely can't make these the same basis. So once you get to this point, you got to go logs. Okay, you got to go logs. So you go logs of 3 to the x minus 2 equals log of 2.5. All right, don't copy this down. I'm just going to put this up just to let you be aware of it. Some books or some people will do the natural log. It doesn't matter. If somebody does a natural log or the book shows you that procedure, it's the same thing. It means no different. I mean, you may want to do ln because you're writing one less letter. I don't know. But I like to do log. Now, what do I do with the x minus 2? Put it out in front. Put parentheses around it. Okay, put parentheses around it. You got a couple options here. Most people will do one thing though. Let's see what your gut instinct is to solve the rest of this. Okay, you got a gut instinct.
Divide log of 3 over.
Okay, that's what most people do, so we're going to do that. You can divide it by log of 3. Now, I'm not going to put anything in my calculator yet or figure anything out because I don't want to round off. Log of 2.5 divided by log of 3. So again, you cannot like make this a subtraction problem. You got to leave that. Final thing to do is just add what to both sides? 2. All right, use your calculator, see what you come up with. So I get x equals log of 2.5 over log of 3 plus 2. Nearest 3 decimal places. Thousands. Evan, what you got?
2.834.
2.834. Agree? All right. One more. This one takes a little bit of room. So don't try to squeeze it into a little spot. It's going to take a little room. Okay, directions. Find the exact and approximate values for x. Okay. Approximate values, that's the decimal. Okay, that is always the decimal. Now, I didn't have you do it on that last one, but like if it said exact value, you could like leave it like this. Like that's all you could do. That would be the exact value. So it would simplify this all the way down. Okay, for one like that, I would leave it, just ask the decimal. Okay, so we're going to want both. Can I write them as the same base? No, not even close. Take the log. Or the natural log. So log of 4 to the 2x plus 1 equals log of 3 to the x minus 2. 2x plus 1 goes out in front. X minus 2 goes out in front. Put parentheses around it. All right, I want to take a second to explain something here because this can be a point of confusion. Log of 4 is a number. Okay, they cannot be separated. You cannot move the 4 from the log and do them separate. It is a number. Now, with that being said, if I had this as an equation, 2x plus 1 times 5 equals x minus 2 times 8, how would you solve that? How would you go from that? You distribute. Everybody can say, I'm going to distribute. You're allowed to distribute on the right. Okay, you would just say, no problem, 10x plus 5, right? Equals 8x minus 16. And then you'd get all the x's on one side and the constants on the other, right? We got the same case. Log of 4 is a number. What do we have to do with it? You got to distribute it. You got to take the log of 4 and you're going to multiply it into both of them. You just got to watch how you write it. Okay, now we cannot multiply like we could over there. But 2x times log of 4, put the 2x first. So just make it 2x log of 4. Okay? 1 times log of 4. That's just log of 4. Equals. All right, what do I got to do with the log of 2 since it's just a constant? You're going to distribute it. Well, we got log of 2 times x. Put that x first because then it'll look like this. If you put it on the other side, it'll look like 2x, which is incorrect. So it's x times log of 2 minus 2 log of 2.
The log of 3.
It is? It is a log of 3. Good catch, Quinn. All right, everybody go erase real quick. Put in 3. That's why. There we go. All right, I'll give you a second to catch up. All right, now here's what you got. You got to be somewhat careful. Like over on the blue where the equation is, like it's not a big deal if you move the 10x or the 8x. Usually we say move the little guy. One thing I'm going to tell you to do here is we do want to get all the x's on one side, but I like to get as few of negatives in the problem as possible. So I want to look at it and I want to carefully consider, do I want to move my x's to the left or I want to move them to the right? You can still get the same answer regardless. It just sometimes makes it easier. So when I say that, how many terms have an x? You got to get everything with an x on the same side. Okay. This is one term with an x. This is one term with an x. So you got to also take into account what else you're moving. I'm going to move this 2x over to that side because when I move this one, it'll make it positive. Regardless, I can't get all pluses. I can't get all positives. That's not going to happen. So I want to get as many as I can. So I'm going to subtract 2x log of 4 here. And that means I have to add 2 log of 3 to both sides. All right, now, okay, that cancels there, and I'm left with log of 4 plus 2 log of 3 equals, those cancel, and I get x log of 3 minus 2x log of 4. So like I said, regardless of what I would have done, I never would have gotten entirely all pluses. So this route, I only have one minus, one negative. The other way, I would have had more negatives and positives. Just makes it uglier. All right, what do I got to do? Connie?
No, sir. I don't know.
Not sure. All right, I got 2 terms with an x. This goes back to when we had, like, if we were solving like x, y minus 3x, we would factor out an x and you'd have y minus 3, right? So you get 2 terms with an x, factor out the x. Log of 4 plus 2 log of 3 equals x. Then what's going to go in the parentheses, though? Adam, what do you think?
X log of 3 minus 2 log of 4.
You got it. You just take that x out from that 2 log of 4 and you're left with that. Hey, at this point, we can get an answer. So all you got to do is divide by what's in parentheses there. Okay. Now you got to watch in your calculator. Log of 3 minus 2 log of 4 divided by log of 3 minus 2 log of 4. I'm just going to rewrite this with the x first while you're putting that in your calculator. So I got log of 4 plus 2 log of 3 over log of 3 minus 2 log of 4. Okay, now it's a calculator problem. Now, depending on which model you got, you might have to put the numerator in parentheses, denominator in parentheses, if you type it all in at once. All right, Peyton, you want to take a stab at it?
I got negative 2.141.
Yes. Negative 2.141. Did you get it? Okay. That is your approximate answer. What did I have highlighted up there? You had to do what? You had to give me the exact answer. Now, here's what the exact answer is. Did you get it? Exact answer. We got to simplify it to you have one log on top, one log on bottom. We're going to use our log rules. So real quick, let's go through this. What do we do with the constant out in front? It becomes a what? It becomes an exponent. So this becomes log of 4 plus log of 3 squared over log of 3 minus log of 4 squared. All right, well, I'm going to cheat here for a little bit. What does 3 squared equal? 3 squared is 9, so that's really going to be a 9. What's 4 squared equal? 16, so that's a 16. Okay, now, what's the top going to become then? Log of 4 plus log of 9. Log of 36. Okay, I need a log of a single number. What's the bottom going to become? Now, it's not going to come out to be a nice number, so we're not going to round it off. What do we do with the 3 to 16? Divide. So just make it log of 3/16. Now, is this a little bit easier? Log of 36 divided by log of 3/16. Oh, wait. Oh. That could have been disastrous. Negative 2.141. Same thing. Okay, this is the exact answer. No decimals. Okay, homework. Not on my math lab. 7 problems, that's it? What was I thinking? Yeah, I'll put it on campus. I know you gotta get packed up and get ready for lunch. I understand.
No idea how it ended.
What we got for lunch there? We buy it?
Yeah.
Okay.
Yeah, I guess so. That's okay.
All right. Have a great day. Yeah. We'll see you, AJ.